All right, so today we are going to take the kind of opposite approach from last time. So last time we said that we were starting with two parallel lines, and if we started with two parallel lines and drew a transversal through them, then we could say, oh, if we have the corresponding angles, then they're going to be the same. If we have the alternate interior angles, then they're going to be the same. If we have the alternate exterior angles, then they're going to be the same. If we have the same side interior angles, then they're going to add up to 180. That's what we said, okay? Today we're going to say we don't know if the lines are parallel. We don't know, okay? So today we're going to say we're going to start with the angles and we're going to use the angles to prove that the lines are parallel. So this is the converse. Circle that word converse. This is not to be confused with the shoes. Anybody wear Converse anymore? Is that a thing? Yes! Yes! So many Converse in this room. I approve of all of you. The red ones, I approve of those the most. That's what I wore in high school. Converse of corresponding angles postulate is kind of saying like the opposite. So if two lines in a transversal form corresponding angles that are congruent. So if you look at the angles and they are congruent, then you can conclude, give it a second, then you can conclude that the lines are parallel. See how that's the opposite? So instead of starting with the lines are parallel, then the angles are congruent, we're starting with the angles are congruent, therefore the lines are parallel. Make sense? Okay. The converse of the alternate interior angles theorem is if two lines in a transversal form alternate interior angles that are congruent, then the lines are parallel. That word converse is really important. So whenever we are using this, we have to say converse alternate interior angles. We have to use that word converse, okay? Alternate exterior angles, again, congruent. Again, that word converse. So you can either circle it with pencil, or if you have highlighters or other colors, you can underline those stars. Look! Well, hello, hold on, these are for you. Okay. Happy birthday. It was a gift, I don't know. Oh. Okay. 5 days? You'll be 27. 27 was a great year for me, so you'll enjoy it. All right, and then the last one, same side interior. The converse of that is that the angles are going to be supplementary, and that will prove that the lines are parallel. Supplementary. That's a difficult one. Okay. All right, for this next section, it was supposed to say which lines are parallel if, and this was supposed to be like if this blank something happens, but then when I underlined it, it like made it look like I put a bunch of spaces. All right, so here are two sets of lines. We have line A and line B. We have line C and line D. So if you look at the picture and you see that angle 1 and angle 2 are congruent, what would we call that? Yes. Yeah, then C and D would be parallel, and what would tell you that they're parallel? Corresponding angles, but we wouldn't say corresponding angles, we would say one specific word before it, the converse of corresponding angles theorem. Does that make sense? So on Friday, we would be like, oh, since the lines are parallel, corresponding angles are congruent. Today, we're going to say C and D are parallel because of the converse of corresponding angles. Does that make sense? So today, when we're saying we're proving that lines are parallel, we're going to use converse, that word in front of everything, okay? So we're going to say C is parallel to D. Remember that, those double lines to prove parallel. And we're going to say converse of corresponding angles. If you don't want to write the word angles because you're starting to feel lazier, I feel ya, you can use this sign for angles. Answered his question as he asked it. That's good. That's good. All right. Angle 2 is congruent to angle 6. Okay, I'm going to do a different, I'm going to do 2 little arcs for this one. Angle 2 is the same as angle 6. These two. Go ahead and erase this one so it doesn't confuse us. Angle 2 and angle 6. Which two lines would be parallel? A and B. Okay. So these are the two lines that would be parallel, and what's our reason why? Yes.
Converse of alternate interior.
Yep. Converse of alternate interior angles. So technically this one is converse of corresponding angles postulate, and this one is converse of alternate interior angles theorem. But mathematicians are okay with this type of lazy. They're okay with dropping off the theorem postulate and just saying converse of that. Okay. This is a wonderful typo on my part. This should say plus. I love when I catch my typos as I'm going through the notes with you guys. Measure of angle 8 plus measure of angle 7. I'm going to go ahead and erase this. Measure of angle 8 plus measure of angle 7. So this angle and this angle are two different sizes, and when you add them together, you get 180 degrees. That means they're supplementary. Okay, so converse of same side interior, and then what lines are parallel? C and D. Okay, so C is parallel to D. Converse of same side interior angles. Okay, and then last one says angle 8 is congruent to angle 3. Angle 8 is congruent to angle 3. Okay, A is parallel to B, and what's the reason? Converse of alternate exterior angles. Perfect. Okay. All right, the next one. Are you jealous that my numbers are in red and yours are not? Color printer. Nobody? Okay, that's cool. All right, so it says we're doing a proof. You guys have probably never done proofs. Is that accurate? Never, ever done proofs. Accurate? Yes? Okay. So two-column proofs, there's different types of proofs. Two-column proofs are the most common. So when we do a two-column proof, we make two columns. Isn't that crazy? Two-column proof. Sounds like what it is. So the left column is the statement. The right column is the reason. Now, two-column proofs, a lot of students are like, Miss Rice, when are we ever going to do this? And the answer is the two-column proof as it's laid out, probably not. But the level of thinking that you do in a two-column proof is actually probably one of the most applicable things from math to the real world as far as like arguments and line of thinking and directly applying math. So the way that a two-column proof works is you say what you know for the statement, and then for the reason you say how you know it. So a proof is just a really good way to lay out an argument. And basically a proof is you laying out an argument so completely that no one can play devil's advocate against you. That you said I did it so completely, so perfectly that no one can tell me I'm wrong. Does that make sense? Okay, so the very first thing you do is you always start with the given information, okay? And usually what I do is I draw on the picture as I do this, okay? So it says the measure of angle 3 plus the measure of angle 8 equals 180, so I'm literally going to write that down. The measure of angle 3 plus the measure of angle 8 equals 180 degrees, and my reason is literally that it was the given information. So that's what I'm starting with, okay? Now, the measure of angle 3 and the measure of angle 8 are not the same measure. They're going to be two different measures. They didn't tell us anything about them being congruent. So I'm going to mark on my paper 3 with one little arc and 8 with two little arcs, just to show that I know what their measures are, but that they're probably different. So that's how I'm going to draw it on the picture. Now, my goal here is to prove that L and M are parallel to each other, and I'm going to use one of those converses to get there. Okay, so my goal is to find corresponding angles, alternate interior, alternate exterior, or same side interior. That's my goal in the end. Okay, so from this, now we can think back about what we know about certain relationships that is definitely true whether or not the lines are parallel, okay? So what angle relationships do we know that does not depend on parallel lines? There's two relationships we know that does not depend on parallel lines. Yes? Supplementary line, like linear pair, right? Two lines that are next to each other, two angles that are next to each other on a straight line make 180 degrees. What else do we know? Starts with a V. We know vertical angles are congruent, right? Okay, so I already can see an angle that is congruent to angle 8. What angle is it? 6. So I'm going to say that for number 2. Angle 6 is congruent to angle 8. What is my reason? Why are they congruent? Starts with a V. They're vertical angles. No one can argue with that. That's literally how vertical angles work. Okay? Now, people are going to say that with these two things, I'm comparing apples and oranges. So they're going to say there, you're congruent, that over here, I'm comparing congruent angles, and up here, I'm talking about the measurements of angles. Does that make sense? They're like, oh, you're comparing two different things. Those are congruent, but those are measures. So we're going to say, fine, if you want to play devil's advocate, that's fine. I will spell it out for you. I'm going to say the measure of angle 6 equals the measure of angle 8. And the reason that I can say that the measurements are the same is because that's what congruent angles means. It means their measurements are the same. Does that make sense? Congruent angles literally have the same measure. See how I'm getting rid of someone who could play devil's advocate with me? That's what a proof does. We are saying, I'm going to lay out all my statements and all my reasons so that you cannot argue with me. Okay, so my reason here is definition of congruent angles. You don't have to shorthand that if you don't want to. Definition of congruent angles. So if I say the angles are congruent, I'm saying their measures are congruent, or the same. Now, I only did that because in step 1, I mentioned the measures of the angles. I mentioned them in step 1. So now I'm saying, okay, their measurements are the same as well. I'm just going to point that out. Okay. Now, look at my drawing in the picture. What do I have in the picture? What information do I have? Six. So we have 6 is congruent to 8. What else do you see? Do we have enough information to say the lines are parallel? Yes, right? By what? Yeah, we're very close, right? So before I can say same side interior, I have to say 3 and 6 add to 180. Does that make sense? I'm going to say, okay, 3 and 6 add to 80 degrees. Okay? And the way that we do this is we say that we used substitution. What did I substitute? I substituted angle 6 for angle 8. Now, you can just write substitution. Some people write substitution property of equality. Does that make sense? I knew that 6 and 8 equal each other, and so I swapped them out. Okay? So now that I say this is true, what is my conclusion now? Yep, now they're parallel, okay? So at the very end, you know that you have finished the proof when you can get down to the end, which was your goal. L is parallel to M. That's your goal. L parallel to M. Miss Rice, I never could have done that on my own. I understand. When I have you guys start with proofs, I'm not going to make you come up with these from your own brain. I'm going to have a list at the bottom of the different pieces you should be using, and your job is going to be to kind of put them in a logical order. Does that make sense? You're not pulling them out of nowhere. You're doing the order based on the pieces you can see. And the reason of this is converse of same side interior. Okay? But the reason this applies to the real world is not because you're going to be doing two-column geometry proofs in the real world, but you want to be able to construct arguments where you're giving a statement and a reason for everything that nobody can argue with. Does that make sense? That's a skill that you can take into the real world. Where is another class that you might specifically take that skill into? Yes? English, maybe? I heard a D word, that debate. Debate class is where this works, right? Like, think about presidential debate, think about any debate where you're trying to make a point, right? Maybe in an English class, going with what Jack said, a persuasive paper, reasons and statements. So this idea, if you strengthen this with math, this is an idea that actually does reach out into the regular world, even if you're not going to do it with math in the future. Does that make sense? Because you really are addressing every little thing in a way that nobody can argue with you. They say, yeah, but, and you're like, nope, I just proved it on paper. I had a reason for every single thing. You can't argue with that. Does that make sense? Okay. All right, go ahead and turn the page. So it says find the degree of the missing angle that would make the lines parallel. So first one, what is the degree of the missing angle? 82. And what would be the reason there? What would make the lines parallel? Converse of alternate exterior. Okay. How about the next one? 130. And what would the reason be? Converse of same side interior. Okay. All right, the next one says find the value of x that would make the lines u and v parallel. So we're doing the same thing, but now we're going to solve an equation. So how should I write the equation for that first example? Let me see if I can make it a little bit more. There we go. How should I write that first equation? Okay. And what theorem? Yeah, converse of same side interior. Okay. So we have 25x plus 55, so I combine like terms, equals 180. And then what should I do? Okay. And what is 180 minus 55? 125 And then what should I do? Divide by 25. And x equals, what's 125 divided by 25? 5. That was very powerful. You guys sounded very empowered as you shouted out that answer. This is one of the reasons I love teaching an honors class, because you guys are very nerdy. 5! No? Okay. Let's move on. It was such a backhanded compliment. I was like, nerds! You know, like the push up of the glasses. Aw. Olivia's like, I feel called out. Don't feel called out. It's because I can say it because I used to wear glasses and I used to do that all the time. And then when I stopped wearing them, I found myself like touching my face all the time, and I was like, my glasses aren't there to push up anymore. All right, next one. What are we doing here? Converse of corresponding. All right. And how should we set up the equation? Okay. Okay, and then what should we do?
Subtract 29 and divide
All right, and then what?
x equals 11. Where'd you get 30?
X equals 11. All right. Subtract 21.
What's it called? Converse of corresponding.
Subtract 21 from each side.
No, like corresponding or the side interior.
Oh, these?
Yeah.
You don't know how to say these?
No. Like, you doesn't remember them.
Oh, the names of the things. That's fair. So if you don't know the names of these, what I would say is take the notes from Friday and make flashcards. Flashcards are a great idea. I do have a little like card sort activity I didn't do that I could give you to like take home and do as extra credit, which helps you like learn the names. I could do that. All right, the last one. Now the picture on mine in color is barely visible, but on yours it's like almost not at all. So here it talks about measure of angle 1, measure of angle 2. Angle 1 is this right here. So if you want to label it on yours, angle 1 is right here. And angle 2 is right here. Angle 1 is this one. And angle 2 is this one. And on yours, they're just really not visible. Yeah. Angle 1 is this one right here. Yep, on top. And angle 2 is this bigger angle right here. Yep, on top. Yep, same side interior. When they talk about the pickets, they're talking about these vertical lines right there, because you know how like when you build a fence, you have like the vertical posts. That's what they're talking about when they say pickets. So a neighbor told Mr. Math, isn't that a clever name I came up with? Okay. A neighbor told Mr. Math that the pickets were not parallel in his fence. If the measure of angle 1 is 35, what does the measure of angle 2 need to be for the pickets to be parallel? Well, but is he? So we have to write and solve an equation to figure out what the measure of angle 2 needs to be for the pickets to be parallel. What converse are we using? Okay, so we're doing converse of same side interior. Okay, and then what equation are we using? Okay, So we have 35 plus the measure of angle 2 equals 180. And so what should the measure of angle 2 be? Oops. So the measure of angle 2 should be 145. And this is a mystery, we don't even know. We don't have to get out a little like protractor. Compass, protractor, compass, protractor, protractor. I always get those two confused.
Compass tells north, south, east, west.
There we go. I have gotten those confused since I was a geometry student in high school. Okay, you know how we can settle this? We can take it into the parking lot, we can fight it out. I'm just kidding. All right. Now, we have another, so before we do that, I wanted to give you guys this resource sheet. This is all the possible reasons I can think of in my brain that you could ever use on a proof. Now, this is meant to be a resource. It is not meant to help you out, okay? This is just so that, because you saw when we were doing the proof, I was like feeding you the answers. This is so that you don't feel like, how in the world could I ever think of something? Does that make sense? Yeah. It's so that you have stuff in front of you. That's like the purpose. Now, like I said, for the proofs, I'm not gonna like leave you stranded and like, flail around and have no idea what you're doing. I'm gonna give you resources. Okay, so the proofs that I'm gonna start you off with, you have the answers. Okay. Yes. Probably not. Okay, I have an extra copy of this proof for the one I already wrote on. So we're gonna do this. We're gonna do this together, but I'm gonna reveal the answers as we go. Okay. So this one starts off by telling you that the lines are already parallel. So are we going to be using converses for any part of this proof? No, because the lines are already parallel. Okay. So since the lines are parallel, how are you going to start off the proof if this is the given information? How do you start off the proof? You're going to give the given information. Okay? So your first couple steps are going to be to say A is parallel to B, C is parallel to D, and the reason for that is that it's the given information. Yep, parallel.
A is parallel to B and C is parallel to D on the same or different?
See how they have two givens? So you have two givens, and they have two givens, and so that's why they gave you two lines to do it. Yeah, so the next one is, they told you that angle 1 is congruent to angle 3. How do you know that angle 1 is congruent to angle 3? How do you know that angle 1 is congruent to angle 3? They're vertical angles, okay? So in that space on the right, this is a two-column proof. They didn't write statement and reason, and if you want to actually add that to your paper, you can. Then on the left side, this is the statement. And this over here is the reason. So 1 is congruent to 3 because they are vertical angles. Vertical angles are congruent. Okay. Then we have angle 3 is congruent to angle 7. And what I would do is, as you're proving these, I would maybe draw it on the picture. 1 and 3 are congruent. Okay. 3 is congruent to 7. What's your reasoning for that? Corresponding angles. Do we have to say converse for that? No, why not? The lines are already parallel. Okay. So for the next one, 3 and 7 are congruent because they are called corresponding angles. They're in the same spot. They're both in kind of like the bottom right position. Okay, so corresponding angles is the next one. Okay. I put theorem, THM is the shorthand for theorem, but you don't have to put theorem. It's acceptable if it's not there. Okay, corresponding angles theorem. All right, 1 and 7 are congruent. Why? Alternate exterior angles. Okay. All right. Now, it's on your list, but I'm going to tell you another reason that they're congruent. Transitive property of congruence. It says, listen to this, if A equals B and B equals C, then A equals C. Okay, now look what we just did. 1 is congruent to 3 and 3 is congruent to 7, so 1 is congruent to 7. Do you guys see that? Okay, so either reason works because we know that 1 and 7 are alternate exterior, so we can use that as our reasoning. But we could also use the transitive property of congruence. Both of those reasons would work. They're both accurate, okay? You can write whichever one you want. You can say alternate exterior because they're parallel lines. That works, okay? But if you want to try out a new reason, transitive property of, you can do equality or congruence. Transitive property of equality is what we use when we're using equal signs. Transitive property of congruence is what we use when we're talking about congruent signs, okay? This is very common. To say if two things are equal and another two things are equal, then I'm going to assume the first and the third one are equal as well. That's very common, okay? You're going to use that a lot. It's that same idea as the substitution that we did last time. Remember that last proof we did that substitution? It's that same idea, okay? And I like this one because it makes a lot of common sense, right? It's pretty logical. Okay. I cannot remember which one I used. I did alternate exterior. Okay. All right. Now, the next one, I don't really like how the person who made this worksheet phrased it. They gave the reason as, if two lines are cut by a transversal, then corresponding angles are congruent. We would have just written corresponding angles. That's what we would have done, okay? Now, what two angles do you think they're talking about if our goal is to get to, say, the angle 1 and angle 11 are the same? Yes. Angle 7 and angle 11, because we're trying to get angle 11 to be included. Does that make sense? We're trying to get angle 11 to be part of the problem. So 7 and 11 are the two that we're talking about here. Okay? 7 and 11 are corresponding angles. So when they did this, they are literally stating the entire definition of what corresponding angles are. You don't have to do that. They were just being overly, it's like when somebody's sucking up in class and they over-answer the question. You know what I'm talking about? That's what this person did when they wrote down their reason. They over-answered the reason. All you had to say was corresponding angles. That's all you had to say. But they were like, if two parallel lines are cut by a transversal, you have corresponding angles. That makes them congruent. That's what they did instead of just saying corresponding angles. And we go like, wow, overachiever, you know? Okay. Yeah, and so at the very end, what's our conclusion to prove angle 1 and angle 11? Transitive property of congruence. Thank you. Oh, don't look at the next one. Yeah. Yeah. All right. Interesting proof. Now, there's a reason that I use this worksheet as notes instead of as homework, because the answers were not there for you, so I'm still helping you walk through it. Like I said, the one that I'm giving you as your practice has answers at the bottom, and you just kind of match them up, okay? So I don't want you to feel stressed. There's a reason we're using this as notes. All right, how do your brains feel about this? Brains are okay? Yeah. I know that sometimes with math, when you learn something new, it's like, well, I feel fine watching you do it, but if I had to do it on my own, I'd have a hard time. Yep, I feel that. Okay, hold on. Go ahead and get the next one started. I know you guys can do that. The first couple parts of the proof are always the easiest. Why are they the easiest? Yeah, you literally just write the given information. So nobody should ever not be able to do the first step of a proof. Everybody can always do the first step. All right, what did we write for the first two lines? Perfect. That's what I wrote. You guys, so good. All right, A is parallel to B, C is parallel to D. The reason is given. Okay. 16 is congruent to 12. Okay, corresponding angles, is it the converse or is it the regular? It is the regular. How do you know? Because the lines were parallel before we got started. Okay? Next, 12 is parallel to 8. Or not parallel. 12 is congruent to 8. How do we know? Same thing, corresponding angles, not the converse, because the lines were parallel before we started. So same side would be, because it's same side interior or same side exterior, it's not just same side. So same side interior means inside the parallel line, same side exterior means outside the parallel lines. These are not both inside or outside the parallel lines, they're in corresponding spots. So they're both in like the upper right-hand corner of the four angles. So upper right corner, upper right corner. That's what makes them corresponding angles. For them to be same side interior, they'd have to be on the same side, but inside the parallel lines. Or for them to be same side exterior, it'd have to be the same side, but on the outside of the parallel lines. So 12 and 16 are corresponding, not same side. So 16 and 19 would be same side interior because they're inside the parallel lines. 12 and 13 would be same side exterior because they're outside the parallel lines. So that's why we don't just say same side, because you're right, that would be misleading. That's why we have to say same side interior or same side exterior, because you're talking about inside parallel lines or outside parallel lines. Corresponding is not saying, corresponding is kind of like same side, but it's talking about like the location as far as, you don't have to say same side. Yeah, but if you ever just put same side, I'd be like, what do you mean? That's only half of the puzzle. Does that make sense? Okay. All right, so the next part is that we want to connect 16 with 8, and how are we going to do that? Transitive property of congruence. 16 and 8 are the same by the transitive property of congruence. Cool. Wasn't that fun? Okay, on the assignment packet, it's got some of these more kind of simple questions that aren't proofs, that are just solving. If you look at the proofs, number 2, the little pieces you can use are so small they're hard to read, and this proof is a little bit overkill. So put an X through 2. You're not going to do this one. The other ones I think are readable. I think you can read them. Just remember that at the very beginning, we're going to start with the given information. It has enough squares that there's one thing per square, everything gets used. Does that make sense? One thing per square, everything gets used. When I went through and made my answer key, I felt like these were all pretty reasonable proofs and that they weren't impossible. I felt like they were definitely like within what would make sense to you guys. Some of the reasons that are on here are not ones that you've necessarily seen already, but I think that they sound right enough that I think that you can get there without being confused. So what I did on this list right here is I left some blanks on the back so that if you want to add something here, you can. Okay? So I will put the answer key up on the back so that you guys can check your answers as you go. Throughout the rest of the period, I am going to come around and check notes from Friday. So have your notes from Friday out so that I can check those, but I'm not going to collect them because I want you guys to be able to keep them. Okay?